This is Professor Pelt, and this is Algebra 2, Chapter 7, Section 5 on solving rational equations. We did the add, subtracting, multiplying, and dividing expressions before. Now we can do the equations. And again, in this section, we'll be using the lowest common denominator. So essentially, we want to get rid of the denominators by using the LCD. So again, factor the denominator completely, determine the LCD, and multiply both sides by the LCD, regardless of how many terms are on both sides. Okay. It'll be easier if there's one term on both sides because they'll cancel immediately. But if there's multiple terms on both sides, it will not. Okay, so in the first case, they are already factored. And the lowest common denominator is the x plus 1 times the 4x plus 5. Because they have nothing in common, it's only what's left over. So we'll leave some room here. 3 and x plus 1 on this side equals 9 over 4x plus 5 on that side. So multiply both sides by the LCD, which is x plus 1 and 4x plus 5. And x plus 1 and 4x. Didn't get the 4 in there properly. 4x plus 5. Now let's fix the plus 5 over here too. Okay, so essentially the x plus 1's cancel on the left, and the 4x plus 5's cancel over here, which gives you an A cross-multiplying equivalent, which some students like to cross-multiply every single problem, which of course doesn't work, and they get more than 2/3 of the problems wrong as a result, because they're not thinking about it. So don't be one of those students that falls into those traps that doesn't think. It's very important to think. So 4 times x, 4x plus 5 on the left, and 9 times x plus 1 on the right. And of course, it's equivalent to cross multiplying just because there's only one term on the left and one term on the right side of the equation. That's the only reason that works. So 12x plus 15 on the left and 9x plus 9 on the right. So we'll move the 9x to one side, so x's are by themselves, and move the 15 to the other side, so the constants are by themselves. So that would be 3x plus 0 equals 0 minus 6. So 3x equals negative 6. Divide by 3, x equals negative 2. Okay. All right, that seems to work here. And just check to make sure when you plug it back in the original problem, it does work properly, which in this case it does. So negative 2 is a valid answer. Okay, let's go to the example B. Okay, so for example B, we have one term on both sides. So we'll again work out to a cross-multiply equivalent, and then for only that reason. And they have nothing in common, so the lowest common denominator is 2x minus 3 times x minus 1, because they have nothing in common, just everything that's left over. So leave a gap, and we'll do 4 times 2x minus 3 on the left, and 2x over x minus 1 on the right. Multiplying by the LCD, which is 2x minus 3 times x minus 1. And on the other side, 2x minus 3 times x minus 1. So over here, the 2x minus 3 cancels, and over here, the x minus 1 cancels, leaving us with 4 times x minus 1 on the left, and 2x times 2x minus 3 on the right. Okay, so we distribute. We get 4x minus 4 equals, nope, not 2. 2 times 2 is 4. Let's see, that'd be 4x squared minus 6x. So minus the 4x and add the 4. Get everything on one side because this is a squared problem. This is going to involve factoring. So 0 equals 4x squared minus 10x plus 4. So we could factor from here, but they are going to have a common denominator or common factor. So we'll factor out a 2. So left with 2x squared minus 5x plus 2. So it's a little bit easier to factor. So left with 2x and 2x. All right, let's double check here. I think we're good so far. So 2 times 2 gives me a 4, which is 1 times 4, or 2 times 2, or -1 and -4, -2 times -2. Okay, so the one that's going to work for us is the double -1 and 4, because that'll multiply to the +4 and add to the -5. Oh, I forgot the 2 on the bottom, right? Because 2x times 2x divided by 2 uses 2x squared. Okay, so that's equivalent there. Okay, so that'll cancel. So now we go over to here, and we get 2x minus 1 equals 0, and the 2x minus 4 equals 0. So if we add 1, 2x equals 1 divided by 2, x equals 1/2. Add 4, 2x equals 4 divided by 2, x equals 2. Okay, if you look at both of these answers, do they in fact work? Well, if you plug them back in, they both work. Neither of them give you 0 in the denominator, so you are good. We have 2 possible answers for this equation. All right, pause the video, go to the next page, and try the student problems for yourself. Okay, student problems. These LCDs have a monomial and a binomial. They have nothing in common, so it's only what's left over, which is 5x and x minus 7. So we'll leave a little gap here and do 3 and 5x and 2 and x minus 7. So over here we'll multiply by 5x and x minus 7. And over here we'll multiply by 5x and x minus 7. So the 5x's cancel, leaving me with 3 times x minus 7. And the x minus 7's cancel, leaving me with 2 times 5x. So that's 3x minus 21 equals 10x. Okay, so we'll minus 3x. So negative 21 equals 7x. Divide by 7, and x is -3. And if you plug in -3, it works. So that is a singular answer that'll work for there. Okay, next one. We have 2 polynomial denominators. They're binomials. They're not in common, so there's nothing in common. It's only what's left, which is x plus 3 and x minus 3. So we'll leave a gap. Multiply by the common denominator over here, which is x plus 3, x minus 3, and x plus 3, x minus 3. And keep in mind what we're doing here. It's an equation. What you do to one side, you do to the other. We don't need to, what I see students doing is they'll often multiply by like this, because they're treated like a fraction. No, that's not necessary. Again, this is properties of equality. These are equations, not expressions. What you do to one side, you do to the other. The goal here is to get rid of the denominators to be able to solve. So the x plus 3's cancel, and the x minus 3's cancel, leaving you with -4 times x minus 3 and 5 times x plus 3. So I guess it's -4x plus 12 when we distribute, and 5x plus 15 when we distribute. So I'll minus 5x to get the x's on one side, and I'll minus 12 to get the constants on the other. So I get -9x plus 0 equals 0 plus 3. So it's -9x equals 3. So if I divide by -9, x equals -1/3. And if you plug that back in, you'll notice that it does work and give you the solution. Okay, one more. Problem C. Again, these are polynomial denominators. They have nothing in common. So the lowest common denominator is 2x plus 5 and 11x plus 8. So we'll rewrite the problem. And multiply on both sides, because what you do to one side of the equation, you must do to the other. So 2x plus 5 times 11x plus 8. And 2x plus 5 times 11x plus 8. Okay, so 11x plus 8 cancels on the right. 2x plus 5 cancels on the left. So I have 1 times 11x plus 8. And on the other side, I have x times 2x plus 5. So if I distribute, I get 11x plus 8 equals 2x squared plus 5x. This is a squared quadratic, so we're going to do factoring to be able to solve this one. So minus 11x and minus 8 to the other side. So we get 0 equals 2x squared. Let's see, 5 and minus 11 is going to be minus 6 minus 8. So I think we're good so far. So a common factor of 2, which we can factor out. You don't have to, but it'll make it a little bit easier. So I get x squared minus 3x minus 4. So that's really a 1 right there. All right, so 1x over 1. So 1 times negative 4 gives me negative 4, which is 1 times 4 or 2 times 2. And one of them has to be negative to get negative 4. Whoops, that negative went the wrong way. Okay, so we need to get a negative 3 in this middle term when they add up and multiply to negative 4, so that's what's going to do it for us. A positive 1 and a negative 4. Okay, since it's a 1 in the denominator, we can just ignore it. So we get 0 equals 2, which can't be true. 0 equals, what's the first one, x plus 1. And 0 equals the x minus 4. So x equals negative 1 or x equals 4. And the question is, do they both work? Well, if you plug them back in, you're good. So we get 2 possible solutions on this problem. And that is the end of part 1 of solving equations.